So we've just asked the question, if alpha is the rate of change of omega with respect to t, omega is the rate of change of theta with respect to t. The question was, if you know alpha and delta t, what can you do with that?
I guess
Right?
find the change in time.
Yeah, you can find delta omega, but how do you know that? First place, that didn't immediately pop into your head that you can find delta omega, did it? Because you're not used to these quantities, you're not used to what they mean, you haven't processed this, right?
Yeah.
What do you have? You have a definition. You have a rate of change of something with respect to something else. You can write down what that means, and all of a sudden, it should hit you right between the eyes. Well, if I know alpha and delta t, there's three quantities here in an equation, and I know two of them, I can solve the equation and find the third one. Does that make sense? The step you're not wanting to take, this is universal, The step you want to skip is the step that tells you what to do. Write out what the definition tells you. If you have nothing else to do, go back to a definition, write out the definition as it applies to that situation. Does that make sense? Okay? Now after a while you get used to doing that sort of thing. Okay, so one thing we want to do here is get used to doing that. Go back to the definition, write it out. You don't know what else to do? You're sitting there staring off into the ozone, as we all do when we get a hard problem. You heard me tell Nathan that in working out the rule for alpha, which is what I did here, and you don't have to know all these details. I wanted you to see some of the algebra that's involved, okay? And get an idea of what's going on here. But I wrote down this equation. I wrote this down as d theta dt, which will be like a delta theta over delta t. What's delta theta over delta t? Is that alpha?
Yeah.
Alpha is the rate of change of angular velocity with respect to time, not the rate of change of your angle with respect to time. Okay? So you have to do the rate of change of theta, because omega is the rate of change of theta, and you don't necessarily need to understand that as soon as I say it, but it was a second derivative. It's a second order equation, what we call a second order equation, okay?
Yeah.
Now, you don't know how fundamentally stupid it was for me to leave that off of there, but it was fundamentally very stupid, okay? Because I was thinking about something else, I wrote it down carelessly, I didn't check it out, right? That's the same thing. And I got a bad differential equation when I solved it, the solution didn't make any sense. So I focused on solving that equation, but that's a very straightforward process. And I couldn't get the solution to make sense. It never occurred to me that I didn't do the fundamental thing and write down that equation right. Now, what you did here, or what you're doing here, if you're not writing this out, is you're staring off into the ozone the same as I was when I was trying to solve that incorrect equation. Okay? Now that equation requires some deeper mathematics, but if you take the usual sequence, complete sequence of 4 math courses starting with calculus, if you happen to be in a field where that's advantageous, you'll know perfectly well how to solve that equation. Okay? So, my main point is use the definition, okay? But understand it's always hard to keep yourself on track. When you're looking out here, something from over here can come along and waylay you as it did me, okay?